All right, we're going to take a look at parallel lines and the angles that are formed when you draw a transversal over top of a set of parallel lines. So we're going to talk about 3 different angle patterns today. We talked about 4 angle patterns in yesterday's lesson. We did complementary angles, which are 2 angles that add to 90, supplementary angles, which are 2 angles that add to 180, reflex angles, which are 2 angles that add to a full circle, which is 360, and the opposite angle theorem, or OAT, which says that 2 angles on an x, on opposite sides of an x, are going to be equal. We will come back to these. So when you have a set of parallel lines are 2 lines that are evenly spaced and do not cross. You can tell that they are parallel because they will have markings, they will have arrows, not the arrows on the end, but they will have arrows somewhere in the middle of the line showing that they are parallel. And then you should have a line crossing them, that's called a transversal. And what it does is it creates angles that are equal or add to certain things. So it creates 3 different parallel line patterns for us. So the first one is alternate angles. And alternate angles is also known as Z pattern because the 2 angles form a Z out of the parallel lines in the transversal. So if I look at angle X, which is this angle here, and I look at angle Y, which is this angle here, together those 2 angles make a Z. Now, it could be a forward Z, it could be a backwards Z, but it definitely kind of looks like a Z. So those 2 angles in Z pattern or alternate angles are equal. They're the same size. So X equals Y. So if I take a look at the example that I have, it says solve for X. I have 2 lines and they are parallel because they have those arrow markings to show that they're parallel. And then this would be my transversal. I have this angle here, which is 53 degrees. And I do like to trace over my angles in a different color or a highlighter or something. And then I have this angle here, which is angle X. And when I trace over the 2 angles, I notice they make a Z. Well, a backwards Z, but it still kind of looks like a Z. So this is our Z pattern, which means that X just equals 53. I don't have to show any work. It's just 53 degrees because of Z pattern. If I take a look at our next angle pattern, those are corresponding angles. Corresponding angles are also known as F pattern. And that is because if you are to trace over the 2 angles, so there's angle X, here's angle Y, they appear to make a letter F. Now, this F could be forwards, it could be backwards, it could be upside down, it could be upside down and backwards. So you really do have to kind of turn your page around to help you see where the patterns are. So in F pattern, these 2 angles are also equal. So corresponding angles or F pattern angles are equal. So you'll notice it's the same diagram as before, but the X has moved. So I still have 53 degrees here. And then this is the angle I'm looking for, which is X. So these are making an F, and it needs to be the angles in the inside corners of the F. So that just means that X is 53 degrees. Now our last one, the co-interior angles, also known as C pattern. So these are interior, they're on the inside, so they're on the insides of the parallel lines and they should be on the same side of the transversal. So if I have this angle X and I have this angle Y, it's pretty square, but it is forming a C. Now it could make a forwards C, it could make a backwards C, but it should make a C. If you look at them, this one is acute and this one is obtuse, so they're clearly not the same size, but they do add to 180 degrees. So I have an example here. I've got that 53 is in the same spot as the last 2 questions, but the X is the one that has moved. The X has moved inside the parallel lines, and that forms a C pattern. So for this one, I do have to show a little bit of work. So I'm going to say X plus 53 equals 180 degrees. And then I'm going to solve that by subtracting 53 degrees from both sides. So 180 take away 53, I think is 127, but I am just going to check that. There it is, it's 127 degrees. In the next video, we'll try a couple of examples.